If you haven't already watched the previous question, it's a good idea to start with that one, because this one I'm going to go through much more quickly. It says, what is the pH and pOH of a solution with a concentration of OH minus of 7.79 times 10 to the minus 5? Is the solution acidic, basic, or neutral? Well, if we look at the concentration of OH minus, the concentration of OH minus is greater than 1 times 10 to the minus 7. Since it's greater than 1 times 10 to the minus 7, this is a basic solution. Now we could find the pOH the same way we find the pH. The pOH is the negative log of the OH minus concentration. So in this case, the pOH is equal to the negative log of 7.79 times 10 to the minus 5. Since when we do this, this has 3 sig figs, our pOH is going to have our placeholder, all right, which is the first digit of the pOH, which is 4. Okay, when we take the negative log of this, if this was 1, it would be 5, but since this is greater than 1, this becomes 4. Now we have 3 sig figs, 108. So these 3 sig figs are all in this number. This number is the placeholder. So 3 decimals here, or 3 sig figs here gives you 3 decimal places on your pOH. Then just like before, the pH plus the pOH is equal to 14. Said another way, the pH equals 14 minus the pOH. In this case, the pH equals, use as many decimals as you need. All right, don't limit your sig figs by the 14. So 14.000 if you want. You don't have to write it necessarily. Minus 4.108. And when you do that math, you find that the pH here is going to be equal to 9.892. So this is the pH of the solution. Note that this number being greater than 1 times 10 to the minus 7 made it basic. A pOH of less than 7 means it's basic. At a pH of greater than 7 means it's basic. So all of these things should line up because basically these are just logarithms of this. So that is basically how the system works.